Alright, so this is chapter 2.1, Patterns in Inductive Reasoning. Let's look at the solve. It reads, fold a piece of paper in half. When you unfold it, the paper is divided into two rectangles. Refold the paper and then fold it in half again. This time when you unfold it, there are 4 rectangles. How many rectangles would you get if you folded a piece of paper in half 8 times? Explain. So, you fold paper in half, then you fold it again. So we're trying to notice a certain pattern. So if you keep on folding it 8 times, in half 8 times, how many rectangles are you going to get? So let's start this section. Alright. Problem 1 states, what are the next 2 terms in the sentence, in this sequence? So, we see that it goes 3 to 9, 9 to 27, 27 to 81. So you notice that from 3 to 9 we multiply by 3. From 9 to 27 we multiply by 3. 27 to 81 we also multiply by 3. So the next 2 terms we're going to multiply by 3. So 81 times 3 is 243. And 243 times 3 is 729. Alright, so let's look at letter B. So letter B also wants us to find the next 2 terms. So the first one is a circle with a triangle. Then the next one is a circle with a square. And then the next term is a circle with a pentagon. Or it should be a pentagon. So, notice that there are 3 sides here, 4 sides right here, 4 vertices should I say. Or sides right there. Alright, and we also have 5 here. So we can assume that the next one will be a hexagon. And the next one will be a heptagon. I'll leave that for you to draw for yourselves. Alright, so now that we found the sequences, why don't you try to got it? After you try to got it, let's move to problem 2. Now, this is when we're talking about conjectures. So, a conjecture is a conclusion you reach using inductive reasoning. Inductive reasoning is finding a pattern. So, problem 2 reads, how about the number of regions does 20 diameters form? So this sounds a little confusing, so let's look. We have a circle, and we cut it, and we use 1 diameter. That means that we have 2 regions, 2 separate ones. So 1 diameter gives us 2 regions. 2 diameters, when you slice this with 2 diameters, you get 4 regions. So 2 diameters, 4 regions. And how about when we do 3 diameters? I can't draw this very well, so we can try. When you use 3 diameters, you actually get 6 regions. This is looking more like candy corn, but use your imagination. Alright, so 6 regions. So how about when you have 20 diameters? If you look at the pattern here, we go from 1 to 2, 2 to 4, 3 to 6, and 22. So 1 to 2 you multiply by 2, 2 to 4 you multiply by 2, 3 to 6 you multiply by 2. So 20 times 2 gives us 40 regions. So why don't you try to got it for problem 2. Alright, so for problem 4, let's look at the graph here. Sales of backpacks at a nationwide company decreased over a period of 6 consecutive months. What conjecture can you make about the number of backpacks that the company will sell in May? So we see in this graph right here, it goes November, December, January, February, March, April, May. You notice that from one line to the next is about 500. So if you see these dots, it goes consistently about 500. So if we look at April, that's about 8,500. So subtract 5 because it's decreasing by 500. In May, roughly you'll sell about 8,000 backpacks. So why don't you try the guide on problem 4? Then we can move to problem 5. And problem 5 is talking about, if I could see it, that would be good. Alright, problem 5 is talking about the counterexample for each conjecture. Now, counterexample is an example that proves that that sentence or the conjecture is incorrect. So, and this becomes very important, especially in higher level math courses. So, what is the counterexample for each conjecture? If the name of the month starts with the letter J, it is a summer month. So we could think of June, July. Well, there's also one more month, January. And January is not in the summer, so therefore that's our counterexample. January starts with J and it is a winter month. Alright. Letter B. You can connect any 3 points to form a triangle. So, this is definitely a triangle and we connect them. Oh, imagine that connected. But, what if we form one from a segment? They definitely are connected, but is not a triangle. So you can definitely form a line. Alright, so why don't you try the got it? And we will do some problems tomorrow.